with classifying conic sections is we're going to review our formulas. So a little review. So you have your circle formula is x minus h squared plus y minus k squared equals r squared. And there's only one formula for a circle, which is nice. And then you have ellipse formulas, which are x minus h squared over a squared plus y minus k squared over b squared equals 1. And in an ellipse formula, the a and the b can change places. So x minus h quantity squared over b squared plus y minus k squared over a squared equals 1. And those are the two ellipse formulas, a being the larger of the two, which tells you where the major axis is. And then just as a side note, your foci equation, c squared equals a squared minus b squared, goes with your ellipse equations. And then the new one, hyperbola equations, x minus h squared over a squared minus y minus k squared over b squared equals 1. And then in a hyperbola equation, the a and the b stay put, but the x and the y may change locations depending on whether the major axis is, the transverse axis, is vertical or horizontal. So your other one would be y minus k squared coming first over a squared minus x minus h squared over b squared equals 1. And the foci equation, c squared equals a squared plus b squared. In the case of a hyperbola, there's also an asymptote equation, y minus k equals slope m times x minus h for the asymptotes. So those are the equations that we have so far. And I want you to look at them and see what the differences are between them. The circle is the only one that isn't equal to 1. It's also the only one that doesn't have fractions underneath of the parentheses. Ellipse and hyperbolas both have x minus h and y minus k, but ellipses, it's being added, and with a hyperbola, it's being subtracted. Ellipses and hyperbolas are both equal to 1. So they are not equal to a number, they're equal to 1. So these are some of the differences that are going to help you identify what conic section you are looking at. So let's do an example. 16x squared minus 9y squared plus 32x plus 18y minus 137 equals 0. So in this form, about the only thing we know for sure is this is not a parabola, because in a parabola, only x or y is squared, but not both of them. So this could be a circle, an ellipse, or a hyperbola. We don't know so far. So the one thing that all three of these have in common is you have to complete the square for x and y. So that's what you're going to want to do first when classifying a conic section, is complete the square. So let's reorganize. 16x squared plus 32x, leave a space, minus 9y squared plus 18y, leave a space, equals, and add the number over to the right, you get 137 space, space. Okay, so now in order to complete the square, we have to remove the scalar. So out of the x's, I need to divide both of those by 16. 16 goes to the front, and you've got x squared plus 2x. Leave a space, which is much nicer. Out of the y's, I can't have the -9. So I'm going to divide a -9 out. So minus 9, and that gives me y squared minus 2y, leave a space. So I've grouped my x's and my y's, and I've removed my scalar. So now we're going to use the magic formula for completing the square, which is b divided by 2 quantity squared. So for the x's, my b is 2. 2 divided by 2 is 1. 1 squared is 1, so we're going to add 1. And then to balance it, we didn't add 1, we added 16 times 1, so we're going to add 16 to the right. Okay, doing the same thing with the y. The b value is a -2. -2 divided by 2 is a -1. Squared is a +1. So we're going to add 1. And then to balance it, we just added a -9 times a 1. So we're going to subtract 9 on the right-hand side. Okay, if you did this right, you should be able to factor these into a perfect square. This would be x plus 1 squared. And then y minus 1 squared equals 137 plus 16 minus 9, which is, oh, we love that number, 144. Okay, so what we've done so far is we're going to complete the square. That's number 1. Now, number 2, 2 out of our 3 shapes are equal to 1. So what we're going to do is force the 1, and then we're going to ask ourselves what the shape is after we force the 1. So the way you force the 1 is you divide 144 by 144, which means you have to divide the other 2 terms by 144. And like most of these, it works out beautifully. 16 goes into 144 9 times, minus y minus 1 squared. 9 goes into 144 16 times, and this equals a 1. Okay, so here is what you mentally want to go through at this point is, number 1, is it subtraction? If it's a yes, you have a hyperbola. If it is a no, you have an ellipse or circle. So that's the first thing you ask yourself is it subtraction? Well, yes, this one is subtraction. So at this point, we may identify it as a hyperbola because it has the subtraction and it's equal to 1. Okay, so if it wasn't subtraction, your second question is, are a squared and b squared equal? If it's a yes, you have a circle and you need to fix it because you have an r squared that needs to be there. If the answer is no, a squared and b squared are not equal, you have an ellipse. So that's the process we're going to follow. Complete the square, force the 1. Ask yourself, is it subtraction or addition? Yes or no. That will determine if it's a hyperbola, or if no, it's an ellipse or a circle. If it's addition, you have to ask yourself, are a squared and b squared equal to each other? If they are, it's a circle and you have to fix it. If they aren't, it's an ellipse and you're done. All right, so let's do another example. Example 2. So 4x squared plus 25y squared minus 16x plus 100y plus 16 equals 0. All right, so the one thing all of them have in common is a perfect square for x and y. So that's the first thing we're going to do. So put the x's together. So 4x squared minus 16x, leave a space. Put the y's together. So plus 25y squared plus 100y, leave a space. Add or subtract numbers to the right, you get a -16 space. Okay, so now we're going to remove the scalar off of the x squared, which means I have to divide both x terms by a 4, and that leaves me with x squared minus 4x, leave a space. To get the scalar off of the y squared, I need to divide by 25. So the 25 goes to the front, and I've got y squared plus 4y, leave a space. All right, now we're going to complete the square. b divided by 2 quantity squared. So -4 divided by 2 is -2. Squared is +4. So I'm going to add 4. And then since 4 is being multiplied by 4, I'm going to add 16 to keep it balanced. Okay, now the y's. 4 divided by 2 is 2. 2 squared is 4, so I'm going to add 4. And then because I just added 4 times 25, I'm going to add 100 to keep the left and the right equal. All right, now we complete the square. So 4 times x minus 2 squared plus 25 times y plus 2 squared equals 100. All right, so we have completed the square. Now the second step, force the 1. So we're going to divide the 100 by 100 to make it a 1, which means I have to divide the other 2 by 100 as well. So that gives me x minus 2 squared over 25 plus y plus 2 squared over 4 equals a 1. So the first question you ask yourself is it subtraction or is it addition? It's addition. So because it's addition, it could be an ellipse or a circle. To figure out which one it is, you ask yourself, is a squared equal to b squared? No, one is 25, one is 4. If they are not equal, this is an ellipse. And we are done. All right, so example 3. This one, we're going to pick it up halfway through the process because I just want to show you what it looks like. So you've been solving this and you end up with something like this. X minus 1 squared over 3 plus y plus 2 squared over 3 equals 1. So the fact that it is addition means ellipse or circle. Now here's how you tell the difference between an ellipse and a circle. Is a squared equal to b squared? In this case, yes, they're both 3's, which means because a and b are the same, this is actually a circle. So what we need to do is fix the equation so it's equal to r squared and it doesn't have anything on the bottom. So the way you fix it is you multiply both sides of the equation by 3. And the 3 will cancel out the 3's on the left. So you have x minus 1 squared plus y plus 2 squared equals 3. And now you have the form of a circle. And if you think about it, it makes sense. I mean, isn't a circle really just an ellipse with the same length on each axis? You know, they're both very much related to each other. And that's one that gets people on the test. They get to this point and they go, oh, it's an ellipse, but these are the same. All right, let's do one more of these and then we're going to wrap this up. Let's do this one. X squared minus 25y squared plus 100y minus 125 equals 0. This one gets people because there isn't a single x term. So we're going to deal with that. Okay, so very first step, complete the square. So I have an x squared, I have a minus 25y squared plus 100y. Leave a space equals 125 space. Okay, the x squared is fine, but the y squared has a negative 25 on it. So I need to divide the y's by negative 25. So that will give me x squared and then a minus 25 times y squared minus 4y equals 125 space. All right, so to complete this square, if you have an x squared, but you don't have an x term, then it's actually just like x minus 0 squared. It's a 0 coordinate, which means, of course, we add 0 to balance it. For the y's, -4 divided by, remember your magic formula, b divided by 2 squared. -4 divided by 2 is -2, squared is 4. So we're going to add 4, but we just added a -25 times 4, so it's going to be -100 to keep it balanced. All right, so let's complete the square. So I have -25, and then y minus 2 squared equals 125 minus 100, which is 25. So we've completed the square. Now we're going to force the 1. So to force the 1, we're going to divide the right side by 25 to make it a 1. But that means we have to divide the other 2 terms by 25 as well. So that gives me x minus 0 squared over 25 minus y minus 2 squared over a 1 equals 1. Okay, so now here's where we ask ourselves, is it added or subtracted? It is subtracted, which means it is a hyperbola. And you are done. And you're ready to graph it if that's your next mission. Any questions?